Now there was some kind of a glitch with the camera, prevented camera from picking up what I did here. But we choose to use this form, the y of t equals e to the negative 5/2 t, etc., with the C1 and C2. The reason being that the initial conditions are maybe a little more easily applied here, although it wouldn't be a problem to apply them in this case. Using this form here, we take the derivative. We notice that this form is a product of this function with this function, so we have to use the product rule. So we start by taking the derivative of e to the negative 5/2 t, which is negative 5/2 e to the negative 5/2 t, multiplied by the second function, and then the first function, e to the negative 5/2 t, multiplied by the derivative of the second function. And these derivatives are very straightforward. You should have no trouble understanding the derivatives and being able to take the derivative of this function by yourself. Just chain product rule, this function times this function. It's an f times a g. Now we're going to apply the initial conditions to this function. The first initial condition is that y of 0 equals 1. Well, y of 0, and we could write out all the terms, but I'm going to skip that, and I'm just going to point. If t is 0, then e to the negative 5/2 t is e to the 0, which is 0. The cosine of square root of 3 over 2t is the cosine of 0. That's 1. C2 sine of square root of 3/2 t is the C2 sine of 0. Sine of 0 is 0. So this term gives us 1. This term gives us C1 times 1, which is just C1, and this term gives us 0. And from that we conclude that C1 equals 1. Okay, again, plugging 0 in here for t, we just get C1. And since y of 0 equals 1, C1 has to be equal to 1. Now we're not going to be that lucky with y prime, so let's see what we get for y prime. Okay, y prime of 0 equals what? Well, it's negative 5/2 e to the 0, so that's going to give us negative 5/2. That's going to be multiplied by C1 times the cosine of 0, which is just C1, plus C2 times the sine of 0, which is just 0. So the first term in y prime gives us negative 5/2 C1. The second term, our e to the negative 5/2 t is going to be 1, because t is 0, e to the 0 is 1. Our sine is going to be 0, our cosine is going to be 1. So what we have here is one multiplied by square root of 3 over 2, and then times 0 plus C2. And this should equal negative 1. Now C1 is 1, so C1 is going to become 1. So we have just negative 5/2 plus square root of 3 over 2 C2 equal to negative 1. Adding 5/2 to both sides, we get the square root of 3 over 2 times C2 equals negative 1 plus 5/2. Well, that's going to be 3/2. So that C2 is 3/2 multiplied by 2 over the square root of 3. so that C2 is just the square root of 3. And our solution to the differential equation with the given initial conditions is y of t equals e to the negative 5/2 t multiplied by c1 cosine of square root of 3 over 2t. Well, that's going to just be cosine of the square root of 3 over 2t. c1 being equal to 1 and c2 being equal to square root of 3. Then we have square root of 3 times the sine of the square root of 3 over 2t. Our solution is typical. So we're going to say that's a typical solution for a characteristic equation with complex solution. We have e to the negative 5/2 t from the real part, and we have sines and cosines from the imaginary part. This is a pattern you'll see as you yourself solve a number of equations of this nature.